All right, so if you have this series here, 4 plus 9 plus 14 plus 19 plus dot dot dot, all the way up to 494. If we're going to use Gauss's method, here, let's try and remember what Gauss's method said. Basically, he rewrote the terms in the opposite descending order. So I'm going to put 4 and then 9, 14. It doesn't look so pretty because of that dot dot dot. I could put a couple more terms in there if you want to, but I have to notice a pattern first. So one thing that I noticed right away is that you're plussing 5 every time. Plus 5, plus 5, plus 5. So really to get from the number 4, which is the first number here, to get all the way to 494, the last number, we just added a bunch of 5s. And so if I want to write it in descending order, you can think about, okay, so I need to subtract 5. So this would be 489. And then you could kind of keep going there. I'm just going to put 3 little dots to show you that that pattern is going to continue, just like we had them on the above one. And so what Gauss said was look at the vertical sums, and they are actually going to be all of the same. So 494 plus 4 is 498. 9 plus 489 is also 498, and you don't see all the terms listed there, but going the backwards way, of course, you could see that that's going to be 498 also. So really what we could do is say, okay, well, let's add this sequence as well as the sequence in reverse. And we notice that we have a bunch of these 498s. Well, how many are there? Well, one of the ways in Gauss's method was, one thing that was really nice was that it just listed the numbers 1 plus 2 plus 3, and he went to like 100. So we knew that when we wrote it in reverse, well, first off, it was really easy to write in reverse because we're just going down by 1 each time, but we knew it went all the way to 1. We would have, again, these vertical sums, 101, 101. But we knew how many 101s that we had, and that was because this basically counted them for us. It told us this was the first number, second number, third number, all the way to this was the 100th number. And that's because it was just a kind of simpler sequence, just adding 1 every time. So what we're looking at here, this is adding 5 every time. This is not the 494th term. We actually have to think about what term number that would be. Well, we know that if we started at the number 4, what we could do is say, well, let's take 494 minus that starting number, which is 490, and think about how many 5s make up 490. And really what that means is what's 490 divided by 5, which is going to be 98. So what that means is we had to add 98 5s in order to get to 494. And so if we think about that, we have the first term plus 5, that gets us a second term, plus another 5, that gets us the third term. So if we're going to add 98 5s, that'll put us at the 99th term. So that's one way to think about it. Another thing that you could do is try and say, okay, well, I know I started with 4 and I added a whole bunch of 5s. I don't know how many. I'm going to write an N to represent the number of 5s. And I know that when I start with 4 and add a whole bunch of 5s, that puts me at 494. So I have a little equation to solve. And now when you go to solve this equation, try and move the 4 over, move the 4 over, you can see that the math is still exactly the same as what we kind of thought of over here. So either way is 100% right, just different ways of thinking about it. So if we again divide by 5, we're going to get n equals 98. And so we know that's the number of 5s. So our first term, the first term, plus 98 5s will put us at 99 terms. Okay, and so we know we're going to add 99 things, and that thing that we're going to add, going back over here, is 498. So we're going to take 99 of these 498s, which if we multiply that, and I would totally use a calculator here, 99 times 498 will be 49,302. And so what that's telling me is if I add up this first row plus this second row, the total there is 49,302. Now we only want to know one row, so we have to split that number in half. So if we take this 49,302 and divide by 2, we get 24,651. That's the sum that we're looking for. So I hope that was helpful. Again, this was a little bit different than just using Gauss's method because we had to figure out which numbered term we were on. Again, it wasn't the 494th term. So hope that helped.